pressure is pretty intense down here. Let's continue with our trip to the core of the Earth. Yeah.
Through the vast, untouchable, uninhabitable bulk of our planet. "70 kilometers down, the Earth's mantle is eerily calm. But the rock is moving, creeping along at 12 centimeters a year. It's moving because it's being heated. The core heats the rock, creating convection currents, just like those in a boiling pan of water. The currents push the mantle rock away from the core, back towards the crust. Then the current pulls the mantle rock along beneath the crust. And as the mantle rock moves, it drags Earth's crust along with it. Since we left home, we've wondered how the tectonic plates move. What triggers earthquakes and volcanoes? The process that builds and moves entire continents. Here's our answer. Giant convection currents. The farther from the core, the cooler the rock. The cooler, denser rock sinks back down. Once the rock sinks, the core heats it up again, and it rises back to the surface to cool. This convection cycle defines our planet. The churning keeps us geologically active. This is the Earth's engine. But the fuel comes from deeper still. "240 kilometers down. A welcome surprise. Clear, hard crystals. Every diamond that sparkles in every ring, in every crown, started life way down here. The rock here is rich in carbon, the same element that makes coal and graphite in pencils. But at 1600 degrees and under 50,000 kilograms of pressure per square centimeter, 50,000 times greater than the pressure on the surface, carbon atoms squeeze into a much tighter arrangement than coal or graphite. It can take up to 3 billion years to create these hardest, most valuable of gems. Natural diamonds only form at this depth, at this temperature, and with this pressure. Humans can't survive here. No drill could reach this far. So how do we mine diamonds? 30 million years ago. Gas trapped in the mantle expanded, like a shaken champagne bottle. Diamonds and rocks from the mantle blasted into the crust. Every diamond we treasure was forged in extreme heat and pressure, blasted to the surface in a series of ancient eruptions. The last time, 30 million years ago. Millions more remain, buried beyond our reach. – 320 kilometers. 500 kilometers beneath the surface. Kilometer after kilometer of hot, green rock. But make the mantle rock transparent, and we can see there's something different down here. A slab of rock that must be hundreds of kilometers wide. Infrared reveals the slab is much cooler than the surrounding mantle rock. The slab is cooler because the rock is saturated with water, seawater. Just when it seemed things couldn't get any stranger, deep inside the Earth's mantle, we've discovered seawater. In this bizarre world, the deeper we travel, the stranger things get. "500 kilometers inside the Earth. The massive slab of rock is saturated with seawater. There's only one possible explanation. This is one of the plates that make up the Earth's crust. As one plate sank beneath another plate, it carried seawater down toward the core. This is part of the Earth's ancient crust. There are other slabs down here too, intruders from another geologic era. One day, millions of years from now, the crust we live on may end up down here. Our world on the surface that feels so solid, so permanent, is anything but. 660 kilometers down, the slabs are piling up. It's an avalanche inside the Earth on an epic scale. Over tens of millions of years, trillions of tons of rock plunge into the mantle's mysterious depths. The colder material sinks and pushes up rock heated by the core. Speed up time, and we can see the rock rising up like hot wax in a lava lamp. It's forcing its way through solid mantle rock, getting softer and more liquid as it rises. On and up, a vast column of hot rock, at least 1,000 kilometers wide, 600 kilometers tall. The column is big enough and hot enough to burn through the crust, to create a volcano far from a plate boundary. This is how we got Hawaii. The volcanic island chain is at the top of a giant column of hot rock that stretches hundreds of kilometers down into the mantle. But we need to travel down, not up, towards the core, not the crust. We've no choice but to dive back in, down through nearly 1,500 degree rock. kilometers. 600 kilometers. 1,000 kilometers. 1,500 kilometers inside the Earth. We're over halfway to the core now. We've traveled through the Earth's crust, into the mantle's deepest depths. The rock is softer, tackier. We're getting hotter. 2,000 kilometers down. 2,300 kilometers. We're getting closer. Closer to the heart of our planet. 3,000 kilometers down. This is it. The force that carves up continents, powers volcanoes and earthquakes. The pivot around which the Earth spins.
Look out, boys. It's really hot down here.
The center of the labyrinth. It's time to enter the core. We've arrived. This is the Earth's core. It's molten iron and nickel. So hot, it glows yellow. And it's bigger than the moon. Everything that exists on Earth exists because of this. The heat that creates earthquakes and volcanoes, that keeps the continents moving and our planet active, comes from inside this. It looks like it's snowing. Oh. As pressure drops between the core and the mantle, impurities rain out of the core's liquid metal, like bubbles escaping from an open soda bottle. cooling crystallized minerals settle as dunes on the underside of the mantle. We've only just reached its outer edge. But already the core is more complex, more beautiful, and more dangerous than we'd ever imagined. Towering tornadoes of liquid metal. There are dozens of them. Each one is thousands of kilometers high, tens of kilometers wide. The currents are spiraling up towards the core's outer edge and sinking back towards the center at a speed of about 10 kilometers a year. Slow by our standards. Supersonic in geological terms. Speed up time by a factor of 50,000, and things get scary. It's 4,000 degrees down here. Such heat creates these columns of hot metal. Then the Earth's rotation twists the columns into giant tornadoes. Together, the spiraling columns turn the core into a giant electromagnet. It's so colossal, the force field it generates extends far beyond the core, through the mantle, the crust, out into space. To create a magnetic shield around our planet. Protecting the Earth from the deadly solar wind. Without these electromagnetic tornadoes, the Earth's surface would be a lifeless desert. Nothing at all would exist. This is truly the perfect storm. A chance combination of motion and heat that keeps our world safe. Every wonder we've seen, every terror, the core's heat drives them all. We can see the heat, feel it, but we still don't know why the core is so hot. What creates all this heat? The answer lies back in time, long before the Earth was born. 4.5 billion years ago, rocks circled the infant sun. As they collided, they released energy as heat. Most of this heat radiated out into space. But a small fraction stayed inside the growing ball of rock. The ball became a planet, and as gravity increased, it pulled the densest elements towards the planet's center. These elements sank, creating friction and heat. And as unstable radioactive elements like uranium, potassium, and thorium broke down, they released even more heat. $4.5 billion years later, wrapped within layers of rock, insulated beneath a blanket of crust, the core is still hot. This heat is the core's greatest gift to us. Everything that makes our world so beautiful, so volatile, owes its existence to this ancient energy source. But our journey isn't over. Right now it's time to enter the planet's inner sanctum, to tunnel through solid iron into the inner core. The pressure is so intense, it will crush us down and squeeze every element out of our bodies until all that remains is carbon, compacted to a single diamond. After a 6,400-kilometer journey, we've reached the absolute center of the Earth. Two forces have dominated our journey: heat and pressure. This is their zenith, their ground zero. It's the planet's hottest place, hotter even than the surface of the sun. Pressure is 3.5 million times stronger than where we live on the surface. We don't know precisely what the inner core is made of, how fast it's growing, when it first appeared, what role it plays. It's a scientific black hole at the heart of our planet. This is where science ends and speculation begins. But from the unknowable, impossible core come the things that make our world possible. Magnetism that protects our world from the sun's deadly rays and allows life to flourish. Mantle currents that drive the plates around the Earth. Precious gems, their beauty captivates us. Their properties help power our technology. Gold, oil, coal. The raw materials that shape and power our civilization. Volcanoes, continents, our changing, living planet. And life itself. Everything we treasure. Everything that makes our planet extraordinary. Everything we can see owes its existence to the one thing we can't see. The core. Unseen, but no longer unknown.
So now we know what's going on down in the core of the Earth. Who would have thought it would be so exciting?